So scale diagrams was the first part of this unit, and similar triangles is the second part. A main study in math throughout high school is triangles. What have you learned about triangles already? Hypotenuse. When can you use a squared plus b squared equals c squared? What? When it's a right angle triangle and you're finding a side or a hypotenuse. Okay? So this topic that we're going to look at is similar triangles. Similar triangles look the same, but one is bigger or smaller, either an enlargement or a reduction of the other one. Okay? So if you have two triangles that look the same, one is just an enlargement of the other one, they have two important facts. Fact number one, does it make sense that the angles are the same? If this was a 90-degree triangle and you made it smaller, does it make sense that that still would be a 90-degree angle triangle? And this length, whatever angle this is right here, will still be the same on this one when it's smaller. And same thing here with this one. Sometimes when we show angles are the same in math, we draw a single line and then another one with a double line. That shows which ones correspond. There are a couple of ways of writing an angle. So if I want to talk about angle C, I can write angle C. That is probably the most typical and easiest way to talk about an angle. We have a little symbol in front that says angle, and then you write C. But you can also talk about an angle by, say, what are the sides that make that angle? If I started at A and then went to C and then went to B, that would make that angle, ACB or BCA. You could choose which way that you wanted to write it. Both of these mean angle C. And you'll notice that when you use the three letters, the letter in the middle is telling you which one it is. There's a reason why sometimes you have to use all three letters. Okay? Let's say that point in the middle is G. And I want to talk about this angle. Can you see why it would not be clear if I said, hey, look at angle G? Because now it's like, well, angle G could be part of this triangle, could be part of this triangle, could be part of this triangle, this triangle, this triangle. Oh my goodness. Right? Which is angle G? You don't know. So this would be an example. If I wanted to talk about that one, I would have to say angle BGC. So the G is in the middle, talking about that angle, but I need the other ones. That's why in that puzzle that I gave you with the circles, they all have three, because they have so many lines. So here, ABC is equal to EFG. ABC is the right angle, is equal to EFG is the right angle. And so this is telling us that all the corresponding angles are equal. That's the first important thing about similar triangles. And all of the corresponding sides are proportional. You may. So that means if this side is 1, this side is 2. if this side were, I mean, this is not to scale, but if I chose this side to be 2, that would mean this side over here has to be 4. And by proportional, it means that if I take this one divided by this one, 2 divided by 1 has to be the same as 4 divided by 2. Are those fractions the same? And what it tells us is our scale factor. Now, a scale factor here, you could, if you go from the little one to the big one, can you see that you're multiplying by 2? If you go from the big one to the little one, you'd be multiplying by 1/2. So technically, if I was looking from left to right, I would say this is a reduction, and the scale factor is 1/2. So the number by which we increase or decrease the sides is called the scale factor. And it's by multiplication. Wow. Yeah, multiplication. I don't know why that word is so hard today. Multiplication.
Scale factor of higher
Enlargement. Okay. Here we have 2 triangles. We have to determine if they are similar or not. So we have to check the 2 things. First thing we have to check are the angles the same. 90, 90, 32, 32. What about the other one? It doesn't say. This is not to scale, by the way. This doesn't actually look like a 32-degree angle. Hey, do you know how to find the other measurement of an angle in a triangle if you know 2 of them? You forgot? No, it's not that.
It's 58.
Oh, it's 58 because Shirk said so? Yeah, I'd be scared too. Are you guys don't know that?
You minus. Yeah, you minus 90 from 30.
No. And it's not a squared plus b squared equals c squared.
You take away 32 from 90.
Why do you take 32 away from 90?
Because that equals 58.
There's a very important property of triangles that you need to know. Okay? Okay. Bonus question for you. Okay? If you get this bonus question right, it's on video. 100% on your next test. Draw me a triangle where the angles do not add up to 180 degrees. Once you do that, bring it in, hand it in, show me the measurements. If it's measured correctly, 100% on your next test. Yes, draw a triangle, measure the angles, and if they don't add up to 180 degrees, you get 100% on your next test.
Does that go for everybody, or is it just
Everybody, anybody can do this.
I'll ask my brother.
There you go.
Oh, because they all have to equal 180, that's why. No, it's not possible. They all have to equal 180.
Okay. Yes, all the angles are the same. This one is 90 and 90. This one is 32, and this one is 32. And this one would be 58 degrees. Obviously, this is not to scale. And this one is also 58 degrees.
Because they all have to add up to equal 180.
Okay, question number 2. Let's see, are the sides proportional? In other words, is there a scale factor where you can go from this one to this one with the corresponding sides? How can I go from 4 to 12 and 3 to 9? Times by 3. Perfect. So we know that these two triangles are similar. Beautiful. And that's, if you want to use the proportions, you take the corresponding sides. So I'm going to circle these ones in red. 12 over 4, that reduces to 3. I'm going to take these ones in purple. Do them in the same order. 9 divided by 3, that equals 3. Are they the same? Yes, we're multiplying by 3. Woo! Talk about, I'll make it a little bigger. Did you have to write what? That was showing the stuff on how to figure it out. Do you want me to put that up again so you can see it some more? That was yesterday. We did our test yesterday. I can erase this. I'll check what I've got.
Do it like Tuesday or Wednesday.
We've got to finish the similar triangles, and we only have one quiz in this unit and one test.
So how will we do a quiz on Tuesday and test on Monday?
We'll see. When we finish this note package, then we'll do our quiz 2 days from then.
So we'll finish probably like
Tomorrow?
Friday? Yeah.
Then Tuesday would be the quiz. Okay. First thing I want you to do is on here, label everything that's given. So ADE is 60 degrees. Where do I put that 60 degrees? ADE would be right there. Label the 60 degrees. Next, AED is 58 degrees. 58 degrees. Fibica is 62 degrees. That's a different unit. FBC is 62 degrees. A to D is 4. So I put a 4 there. A to E is 3.8. Put a 3.8 there. D to E is 1.7. And F to C is 10.
What? That doesn't make sense. It doesn't make sense.
So, if these are similar, okay, first of all, angles in a triangle always add up to how many degrees? 180. So that means I can figure this side out has to be 62, which corresponds to the 62 there. And then if angles in similar triangles are the same, you can figure out this angle has to be 60 and this angle has to be 58. Now the sides are proportional. Question? Yeah. The sides are proportional, which means when I go from here to here, I'm multiplying by something. I take out my calculator and say 1.7 times what is 10? So I go 10 divided by 1.7. It's 5.88. So then I could take 4 and also multiply it by 5.88, and I get this side to be 23.5. And I could take 3.8 and multiply it by 5.88, and I get 22.4. Sometimes we use numbers that aren't whole numbers or what are sometimes considered nice numbers, like 5.88. Not something you could do mental math. You would need a calculator for this. But sometimes we use numbers like that to make sure we really understand what the idea is. Dealing with harder numbers or with more awkward numbers really means you have to understand what has to happen. So that's why I like to draw an arrow from one triangle to the next and say, hey, I multiplied by 5.88. What would you have to do if you went backwards? You'd have to divide by 5.88. Perfect. Yes or no and justify. No.
Because 5 times 2 is 10, but 3 times 2 is not 7. By the same number.
Hmm. How'd the next one go? Ooh, I likey. I likey.
You gotta find the hypotenuse of the small triangle first.
Can you see in this question that there are two similar triangles? And can you tell me which triangle is similar to which triangle? Do you know the symbol for similar? In this triangle, ABD is similar to ECD. Equal means they're exactly the same. Similar is one, they look the same, but one is bigger than the other. Okay? They would have the same proportions. It'd be like making a mini U, all exactly the same proportions, they would be similar, but, right. They're not equal, but they look the same, right? So, can you see the big triangle here in yellow is similar to the small purple triangle here. And sometimes what we'll do in a question like this is we'll draw the similar triangles separate on the same page and label what we know. What do we know here? We know that this is 5.4, and we know that this is 10.2, and we know how long is this side of the yellow one? 17.2. And you want to find x. Since they're similar, I would go like this. I draw my arrow this way. I always like going from the smaller one to the bigger one. How much do we need to multiply by? $1.686. How did I figure that out? I took 17.2 and divided it by 10.2. And I found out that the yellow one is 1.686 times bigger. Can you see this is x? If they're similar, which they are, I would have to multiply my 5.4 times by 1.686 to find x. So generally what we try to do in math is we try not to round until the very end. So I actually used all my decimal places from the 1.686. And then, and what you, like that. And sometimes like when you got your answer here, I'll just show you. So let's say you got that answer. You could just go times and it automatically takes your answer.
Technically, 1, 2 would be wrong. Unless you multiplied it just by.
No, I rounded up to 1.69 and then I times it by. Yeah.
We're almost done the booklet. We'll do one more question for today.
Okay. Wait, what? Why are we drawing this?
There's a statue, 8 meters tall. Casts a shadow 3 meters long. Does that make sense?
Just draw a stick figure on a podium.
What is the height of a person
Oh, it's a triangle.
who casts a shadow 0.6 meters long? Why do shadows create similar triangles? Because. Nice. We should. Right?
Is that 8
Half a
meters?
mark if you just say cuz.
Is that 8 meters with just the human or the?
I would go right to the ground level. And then the shadow technically counts from there as well. These are similar triangles because both are standing upright, so both would have 90 degrees right here. The sun's rays, it's not like the sun points on you differently than somebody else. The sun's rays come in parallel, meaning that this angle and this angle are the same, and this angle and this angle would be the same. And if all the angles are the same, it makes a similar triangle. So again, I would, even though I drew it as a reduction, I would probably draw my arrow this way and say, what would I have to multiply by to get from 0.6 to 3? So I do 3 on my calculator, 3 divided by 0.6. You're multiplying by 5. So now if you're going this way, you're going to need to divide by 5. 1.6 meters tall. So we have 10 minutes left. I'm going to let you try the next question on your own. Or do you want to do it together? Together? And then tomorrow in class, bring your textbooks. Try it first by yourself. The next one. And then tomorrow in class, bring your textbooks because I'm going to give you some time to work on that homework.
So if he's 175 centimeters, he'd be 1.75 meters.
That's right. Here, I'll show you. So we've got to have our tree.
It's actually 0.405, but
There's my tree.
oh wow. Huh. That's better than Weber's. Weber's were bad.
There we go. There's our tree casting the shadow that is 22 meters. So we draw our triangle.
Why would we take one color like a purple and you would draw a stick?
22 meters. And then this is really cool. This is really cool because then you know how tall you are. Your shadow, so his height is 1.75 meters. His shadow is 2.4 meters. This is the power of similar triangles. So we notice going from here to here, how much are you multiplying by? 22 divided by 2.4. 9.167. Then you could take this length and multiply it by 9.167. And you get 16.04. How'd you do? Okay.